So in the last class, we discussed about the IoT protocols. We started discussing about the IoT protocols, and the protocols means that it is a set of rules that define how the data transmission should happen over the physical layer or the certain medium. So it defines how we can, exchange the data, how we can, define the data packets, um, and in what format we can define the data packets and how they should be encrypted and also authenticated uh, for the for the in the transmission. So all these standards that define the different methods of transmission are known as the protocols, basically. So there are many protocols, and those protocols can be defined under different layers. So we have discussed about different layers under which IoT protocols are defined. So basically, 5 layers are considered: physical layer, data link layer, network layer, transport layer, application layer, and so on. So basically, 5 layers are there that we are considering. And we will be talking about the physical layer, data link layer, and network layer, and transport layer basically today. So we started talking about the physical and data link layer. So in that layer, basically we are talking about the communication technologies that we are using to send the data physically over a certain medium. So basically, we are talking about the different mediums through which we are sending the data. It could be a wireless medium or it could be wired medium. So based on the different medium, based on the different kind of hardware that we are using, the protocols that we are using will be different. So in here, we are talking about different protocols like ZigBee. BLE means Bluetooth low energy, Wi-Fi. Then LoRa communication. NFC means near field communication. Cellular communications, Z-wave communications. On top of these, we will be talking about Ethernet and so on. And then we will discuss about the internet protocols. So before going on to the internet protocols, we will first talk about the physical layer protocols. So in the last class, we discussed about the physical layer protocols, starting with the Bluetooth, Wi-Fi protocols. So today I will continue from there. And we discussed about the Bluetooth low energy protocol, which is used to define the standard of the communication for the Bluetooth enabled communication. So Bluetooth enabled communication uh, is there are two types: Bluetooth only and Bluetooth low energy. So the difference between Bluetooth and Bluetooth low energy is mainly that the power used to transmit the signal in the Bluetooth low energy case is lower than the standard Bluetooth communication. And then the Bluetooth low energy is used for, I mean, short range communications, just like the Bluetooth, the standard Bluetooth, and they used to connect to wearable devices, sensors, and other smart home devices. So Bluetooth low energy is preferred in most cases because when we are talking about IoT networks, the IoT networks try to optimize the energy consumption and then try to reduce it a lot. So therefore, we are looking for technologies that are more energy conservative or energy efficient. And therefore, when we define some communication standard for our IoT network, we try to obtain the one with which consumes lesser energy. So Bluetooth low energy, therefore, is one of the optimal ways of connecting to other devices via Bluetooth, while also conserving power. So when we talk about the Wi-Fi, Wi-Fi is another technology, communication technology, which has been defined as a communication technology for IoT networks. So there are many standards that define the Wi-Fi communication. So those standards are uh, what we call as the protocols that are defined for the Wi-Fi communication. So there are many standards that are defined for the Wi-Fi communication. So basically 802.11 protocol is the standard protocol for Wi-Fi. So we need to follow the protocol standards that are defined under 802.11 uh, to uh, enable Wi-Fi communication. So there are different types of this protocol. I mean, 802.11 has different types under its main standards. It has other subdivisions, so other sub standards that define different protocols or different standards for the specific communication in a specific situation. So, as I said before, the 802.11a is operating under 5 gigahertz band. 802.B and 802.11g operate in the 2.4 gigahertz band. Then 802.11n operates in the 2.4 and 5 gigahertz band, and so on. There are such kind of standards, different standards that define the operation of the Wi-Fi in a specific frequency band. And also, you might think that like some standards are working in the same frequency band, right? 802.11g and 802.11b works in the same frequency band. However, the standards are somewhat different, so that the output data rate that we can achieve from these standards are different. Apart from the Wi-Fi standards, we also discussed and we focus on the mobile communication systems, or we normally call these mobile communication technology as 2G, 3G, 4G technologies. So 2G, 3G, 4G technologies are widely available in the environment for our usage. We use it daily for our normal, call transmissions and to retrieve data. Now, these communications can also be used in IoT situations, IoT networks. So, its main advantage when compared to Wi-Fi, Bluetooth is that while also achieving data rates of about 9.6 kilobits per second with 2G up to 100 megabits per second, it can have a very high range of communication up to kilometers of distance. So it is a very stable communication even now, which enables us to communicate over kilometers of distance. So therefore, still these cellular communications are preferred over Wi-Fi, Bluetooth in cases where we want to communicate over large distances. And then when we talk about the LoRa communication, LoRa is another special communication technology, and it has its own standards of operation. And the LoRa communication is popular for many reasons. So one of the reasons is that it is a low power communication technology. So in IoT communications, this is a plus point. Second thing is that it is a long range wireless communication protocol, and therefore it is useful for communication scenarios where we need the communication to happen over maybe multiples of kilometers. It is defined in the standards that the LoRa communication can communicate up to about 5 to 15 kilometers of distance. So therefore, LoRa communications is preferred in most cases. However, we also have to be concerned in here about the amount of data that the LoRa communication can carry per second. So the amount of data that it can carry is not that high when you compare with the other types of communications. So the data rate that we can achieve from LoRa communication, it needs to be considered uh, as well to use before using that communication. So if you are using LoRa communication, you can use a certain LoRa module. There are LoRa modules that you can buy, and you can use that in your embedded system that is uh, placed near the sensor or placed with the sensor at the edge of the network. And you can use the LoRa communication to transmit your data to a certain access point or a certain gateway. And therefore, afterwards, you can send it through the gateway to the network, internet, I mean, through the internet up to the destination servers. So anyway, like LoRa communication is used to send the, I mean, LoRa communication is used to transmit data over long distances. And LoRa is LoRa is named as the physical layer protocol. And if you are considering the network layer protocol, this is the physical layer protocol. If you consider the network layer protocol, its equivalent network layer protocol is the LoRaWAN technology. So this is the network layer protocol. So if you are doing a communication using LoRa technology over the physical layer, data link layer, network layer, then you will be using these protocols to do the communication. So LoRa protocol will be used to do the communication in the physical layer. Then LoRaWAN technology will be used to do the communication in the network layer. When we are using the LoRa technology. So afterwards, we can use the standard transport layer and application layer protocols to do the rest of the data decoding process. If you have any questions, please let me know. Next, I'm going to talk about the Ethernet communication technology. Ethernet technology has its own standards to enable the communication. So the standards that is defined for Ethernet is IEEE 802.3, which is a collection of wired Ethernet standards for a link layer communication. So Ethernet communication is done via, wired medium. So it is not the wireless communication. So it has standard standard protocols defined for communication using different mediums. So there are two main, standards that I would like to discuss, which are basically 802.3i, which uses a copper twisted pair connection um, cable. Okay, so the copper twisted pair connection cable is this one. Uh, so uh, these cables are used to transmit the data uh, that we send over using a Ethernet connection over to a long distance. So the data rates that we can achieve from that from this the twisted pair connection will be about 10 megabits per second. Apart from that, when we talk about the 802.3 AE, which is another standard, it is used for the communication over the internet, over the fiber communications. So fiber cables based communication that we can do uh, uh, to data over these uh, it is done over the fiber cables. And about the data rate that we can achieve is about 10 gigabits per second. There's a higher data rate that we can achieve through the Ethernet over fiber connection, and the standard will be 802.3 AE protocol, right? So, uh, so basically, the Ethernet over the fiber method achieves more data rate than the twisted pair connection. So, those are the mediums, basic mediums that we can use for Ethernet connections: fiber, twisted pair. Also, we can use coaxial cable. Coaxial cable is also used in average for communications. However, like there are some advantages and disadvantages of using each of the method. And I would like to talk about, in summary, about like all the communication technologies we have discussed so far. And in terms of parameters such as the communication range and the data rates, and also on top of this, the energy consumption. So there are many communication technologies that are presented here, right? So when we talk about the communication range, we can see when we go along this x-axis, the communication range increases. So the communication technologies that use lower range or less communication range, or that has less communication range, are basically uh, NFC, near field communication, Zigbee, which is also, I mean, up to 100 meters of communication range. You can check on that further as well. And then Bluetooth communication, Bluetooth low energy technology, and then Wi-Fi technology. Uh, so these are known as short range wireless communication technologies. Short range communications. That means they are like below 1 kilometer, below maybe 500 meters of communication. So these short range communications are basically used for smart home applications. So very popularly used inside homes and inside offices, and some enclosed spaces where we have communication within short ranges. And then when we go to the other technologies over the communication range, we can see that the cellular communication range is uh, like which is operated by the network infrastructures of 2G, 3G, 4G, 5G. They are able to communicate over multiple kilometers, about 1 to 3 kilometers of distance from a single base station. So it depends with the type of technology that you are using. So if you are using 2G communication, you can reach a higher coverage than 3G. If you are using 3G, you have more coverage than 4G. You're using 4G, you're having more coverage than 5G, and so on. So the main reason, according to my understanding, is that once we are going further ahead with these generations, we're trying to increase the data rate that is achieved by the user. So in order to give the higher data rate, we need to use higher frequency bands, and then we need to therefore make the coverage a little less than before, because the high frequency signals, although they enable us to achieve high data rates, they actually attenuate very quickly once it is propagating in the air. So it has less stability over the over once it is propagating in the medium. So, due to its attenuations, the coverage range of the signal is getting less, or is lower in 5G communications when you compare with the previous generations of communications. That is in general. However, like if you have specific applications where you want to reach high ranges or longer ranges of communications. There are also methods to achieve that using the specific antennas and specific technologies such as beamforming, multi-input, multi-output technologies, different multiplexing schemes, and so on. So there are many methods to improve the data rate of the existing wireless technology. However, in general, once you are increasing or improving the generation, since the frequency bands of frequency of transmission increases, the attenuation decreases, thereby decreasing the coverage or communication range of the communication. So anyway, 2G, 3G, 4G, 5G are like very stable communication technologies even now at present, where you can use it anywhere when you're traveling in the outdoor environment. So if you don't have Wi-Fi, if you don't have any other short-range communications, uh, cellular communication provides the medium for communication. Then, when we talk about the other this uh, low power WAN technologies, or I mean communication technologies that enable long range communications with low power. So some examples are LoRa communication. So we discussed about this before. Then Sigfox communication, and then narrowband IoT communications. So LoRa communication can reach up to 5 to 15 kilometers of range as defined by the data sheets and the manuals. Uh, and likewise, these narrowband IoT Sigfox communications can reach communication range even more than the cellular communication. So these kind of long range communication technologies are useful for situations that for specific situations uh, where we have the sensors or sensor nodes placed in faraway locations from the access point. So then likewise, we have the communication range. So however, when we talk about the data rates, the amount of data rate that can be achieved from the different technologies, we can see that the LoRa communication is lower than the cellular communication. So therefore, actually, the data rates that for example, the cellular communication can reach is much higher than most of the other communication technologies. However, like Wi-Fi communication technology is still, it's a strong communication technology that enables wireless communication with like a satisfactory data rate. So, so based on these kind of um, information, we can decide which type of communication technology is best suited for our IoT network, right? So we will now actually try to, categorize these communication technologies under the communication range, data rate, and energy consumption criteria. So I will share my whiteboard for that. So in the meantime, I will also share with you the attendance monitoring So if possible, please mark your attendance. I hope you can view it. Right. So I hope you have marked your attendance. So I will keep sharing this for some time. I will, in the meantime, I will explain to you about the different wireless communication technologies and how we can categorize them based on their power consumption, communication range, and data rates. So I will draw a small table. So we have different communication technologies. So when we take different technologies, we will be able to uh, categorize them. So let's take the first one, the Bluetooth, and we will categorize them based on the power consumption, communication range, and data rate. So the technology is basically Bluetooth technology. The communication range is, the power consumption is basically, we will call that medium. It consumes some energy. Power consumption is medium level. So we will get into power consumption levels of high as well. So when we compare with those technologies, the Bluetooth technology has a medium power consumption. So the communication range is of about 100 meters. The Bluetooth can communicate. Then, then we can also reach a data rate of 3 megabits per second, right? About 3 megabits per second. So I think it is considerably a good data rate that we can achieve megabits per second. So when we talk about the Bluetooth low energy, BLE, the Bluetooth low energy, it has a lower energy consumption than the Bluetooth. So lower than the normal Bluetooth. It has a coverage of about actually a little bit more than 100 meters, a little bit more than 100 meters. And its data rates, however, will be lower than the normal Bluetooth, which would be in the range of 125 kilobits per second and up to uh, about 2 megabits, up to about 2 megabits per second. So we can achieve up to 2 megabits per second, but the data rates are not as high as Bluetooth in some situations. So Bluetooth low energy has a lower energy consumption, which is a good advantage. And also it can reach more longer distance than the normal Bluetooth. So then when we talk about the Wi-Fi, Wi-Fi will have a higher energy consumption than Bluetooth. So its energy consumption is high, and therefore it's like its usage in some applications can be reconsidered. So the energy consumption is high in Wi-Fi, and therefore we might need to opt for other technologies when we use the communication for energy constraint situations. So when we have Wi-Fi, we are able to reach only about 1 to 10 meters if you consider indoor scenario. And however, you can extend this using repeaters, Wi-Fi extenders, and we can reach higher communication ranges than this 10 meters. So we do currently have repeaters and extenders to extend this further, right? To extend this communication range further, we can use extenders and repeaters. So we can achieve more communication range than 10 meters. So Wi-Fi communication, of course, reaches, has higher data rates of about 10 to 100 megabits per second. It has 10 to 100 megabits per second. So it has the highest, I think, data rate so far when you consider about the data rate only. Also, you can have a higher internet speed with the Wi-Fi. Then we talk about the LoRa communication. The LoRa communication that we talked about has a low energy consumption, and therefore is preferred for IoT applications. Can reach about 5 to 15 kilometers as per given in the manuals, and then it can have a data rate of about zero point 0.3 up to 50 kilobits per second. So zero point 3 up to 50 kilobits per second. 0.3 up to about 50 kilobits per second. So which is a lower value when you consider about the Wi-Fi, for example, and even when we consider Bluetooth. However, these LoRa communication can go far along far distances and transmit signals to a distance of multiple kilometers. So it can transmit data over multiple kilometers, and LoRa communication might not be highly uh, uh, data efficient, or it doesn't have high throughput. However, like it can send data over large distances or long distances. And based on these characteristics, we need to select the LoRa communication for specific scenarios, and depending on the application that we are considering. So apart from that, we will talk about the Zigbee communication. Zigbee communication, it is also popular short-range communication technology. It is also having low energy consumption. Its communication range is about 10 to 100 meters. So it has a lower communication range, and it also has a data rate of 20 to 250 kilobits per second. So I hope you have written down this OTP code 5437, and I hope you have marked your attendance. So I will make this larger, and so we can see that we are able to uh, obtain kilobits per second data rates with the Zigbee. When we talk about the other technologies such as the near field communication, I will write here. The near field communication is another popular or demanding technology that is rising now because of its usefulness in short range communications and its security. So near field communication provides more security than most of other communication methods. Um, so we will talk about that a bit further in the future as well. NFC enables encryption, decryption methods into its data transmission. So the data that NFC is transmitting is encrypted. So only the user, specific person or the user device can access this data by authenticating the data. So NFC communication is useful for security forward applications such as payments, making payments, money transactions. So in situations where we want to do money transactions wirelessly without entering the bank details each and every time, NFC communication can be used to authenticate the transaction by giving our, our uh, maybe password, some kind of authenticating um, data. So NFC is therefore another important wireless technology that we need to study and will be used. This technology will be used for, as I said, security forward applications, which will be popular in the future. So NFC consumes low energy, which is an advantage for us. And then it has communication ranges of below 10 centimeters. So therefore, this is useful for very short range communications, which are almost that the transmitter and receiver have to be in the same place. So so this is useful for contactless payments, where you bring the uh, phone bring your phone very near to the this machine that accepts the payment, and this is your phone. You need to bring your phone very close to the machine that accepts the payment, and then payment details will be transferred wirelessly to the other device. So however, like you can send the data over wireless medium. So NFC is useful for contactless payments. So NFC can be useful for us in the future, where where we can use these contactless payments in everywhere in our payments. So we can do payments in the cafeteria or the canteen without giving our card or giving our cash. Or else we can do the payments in other places, such as the bus or bank. So these applications will be there for NFC. So most probably they will be implemented. So then we also have other communication technologies. So another communication technology that will be useful will be the communication technology that is uh, based on the 6LoWPAN protocol. So we will discuss about that protocol later as well once we are discussing about the network layer. So I think 6LoWPAN is a protocol that is basically 6LoWPAN is a protocol that is basically defined for the network layer, and this network layer protocol is governing the network layer transmissions. So the communication technologies that use the network layer protocol, this 6LoWPAN protocol, can um, achieve the standards defined for the network layer transmissions with respect to the packet header formats and packet header compressions and so on. So we will talk about this protocol basically in the network layer. However, this protocol is also very much connected with these physical layer communication protocols. So I mean, a 6LoWPAN protocol, which is utilized in the network layer, will be uh, will be integrated with one of these physical layer protocols when we want to set up a communication in energy constrained environments, so right. So in energy constrained environments, we will be using 6LoWPAN protocol. So in energy constrained environments, we can use Wi-Fi technologies or Zigbee technologies or LoRa technologies to communicate over the physical layer. So when we go up in the network layer, in the network layer, we will be using protocols such as 6LoWPAN, which will enable us to save energy under the network layer work. So likewise, we'll be using protocols in the different layers suitably. And the most important thing is the application that we are considering. So based on that application, we want to select the best technology. So based on the technology we select, we need to follow the specific protocol. So therefore, we need to, like when we are designing IoT networks, we need to focus on the application, and based on the application, we need to select the different technologies of communication, for example, that we are going to use. And then based on the technologies, we need to follow the protocols that define define the communication that use that technology. So these protocols define the standards uh, of doing the communication uh, using the specific technologies. So the technology could be, we could be using Wi-Fi, we could be using Bluetooth. So whatever the technology that we are using, we need to refer the protocol that gives the standards of doing this communication using the Wi-Fi, Bluetooth, LoRa, etc. So therefore, like once we are given a certain application to design a certain IoT network, we need to decide which technologies we are going to use. Based on the technologies, we will know what are the protocols that will be followed, and in which layer these protocols will be followed. So if you have any questions, you can let me know. So I will share the PowerPoint presentation again. Mainly, we will be discussing about network layer protocols, mainly 3 network layer protocols. So we'll be discussing about these 3 protocols: IPv4, IPv6, and 6LoWPAN protocols. So these protocols are used to basically define the standards that uh, that govern the communication in the network functions, so network layer functions, such as, there are network layer functions that should be done. So in the network layer, we will be basically, generating the packet according to a certain standards. So the packet layer, packet content will be defined in a certain standard format. And then the transmission and reception of the data packets will be governed by this network layer protocol. So this process will be assisted by these IPv4, IPv6, and 6LoWPAN protocols. Depending on the protocol we select, that certain protocol will help us in doing the packet transmission from the source to the destination in the optimal manner. So these IPv4, IPv6 protocols and 6LoWPAN protocol, they provide a unique address to each of the device in the network, such that the devices who are using the network can be uniquely identified. By uniquely identifying, then each of the routers and switches that are in the network can quickly identify in what direction the data packet should be sent. Okay, so such likewise the IP protocols or internet protocols help us to guide the packet in the correct direction and send that packet to the correct destination. So we will talk about these internet protocols uh, further, but I believe like you have learned about some facts regarding internet protocols before. I don't know whether you have learned. However, have you learned about the internet protocols before in one of your modules? The IPv4, IPv6 protocols? Have you learned about IPv4, IPv6 protocols? Yes or no? Can you let me know? Yes or no? IPv4. Have you heard about IPv4? Internet Protocol IPv4. Have you learned about addressing, how to address a device using IPv4 protocol? Have you have you learned about this IPv4 address format? I think I'm not sharing with you the screen correctly, right? You didn't mention it to me. So have you learned about the IPv4 protocols? Great. So I think I don't know whether you can see my screen. I'm sharing my screen, but I think it's not visible. So anyway, so I think I will also share with you another thing, which is that I want to also share with you the LMS assignment that I have uploaded in the LMS. So in the LMS, I have uploaded an assignment for you to complete. So you have to go to the assignment I have uploaded last, which is under week 5, ESP Now Range Measurement and Analysis. Go there, and in here you have the instruction sheet. So in there you have to follow these steps and do the assignment based on the ESP Now protocol, which we discussed about in the last interactive class of this module. So ESP Now is a protocol that is introduced by ESP microcontrollers, and that ESP Now protocol is enabled in the ESP microcontrollers, and this ESP Now protocol is basically enabled under Arduino IDE. So there's a separate library that enables this ESP Now protocol. ESP Now protocol enables us to have communication directly with one ESP microcontroller to another ESP controller. So using this communication, you can communicate over a short range. So in this experiment, what I want you to find out is like, what is the distance of communication that what is the communication range of this ESP Now protocol? So you need to go out in the environment and collect some measurements um, using the microcontrollers. One can act as the transmitter, other can act as the receiver, and you can see up to which distance maximum the communication can be done reliably. You can send some data and you can check up to which distance you are receiving the data reliably. So after checking the data, you can decide what is the average communication range of the ESP-NOW protocol. So I want you to go through this instruction sheet. And one thing I want to mention is that I want you to mention the specific locations you are choosing using a Google map. So I want you to include the images of the Google map, and I want you to show in that what are the locations you have chosen as the transmission location and the reception locations. And so you can choose these locations and mention them in the Google map. And you can do the same experiment of measuring the communication range for different situations. So you can consider like a situation where there's rain. One thing, rain, then there's no rain. Sun, the sunny. So with regard to weather, you can consider two. You can take two measurements. Then you can consider night, day and night. So likewise, you can consider different uh, different environments for testing the communication range. So after considering the different environments, you need to decide what is the average communication range possible with this ESP-NOW protocol. And then after getting those data, you can present that data maybe using a table, and then you can finally find the average communication range. You can give that as a value. And then I want you to include the data of your team members in the report very clearly with the student IDs and the names. And also finally give the conclusion with all the detail about the communication range that is possible with the ESP-NOW protocol based on your experiments. And also you can mention the factors that affect the communication. You can mention things like, okay, the rain affected the communication range, the daytime or the nighttime, the light intensity in the environment affected the communication range. Those things you can mention in your conclusion as the factors that affect the communication range. So I believe with that, I will end today's lesson. I hope you understood some things and you were able to understand the concepts I have presented. So if you have any questions, you can let me know. If you don't have any questions, you can leave. So thank you so much for coming and participating in today's lecture. So see you at the interactive class.